Hi, welcome to Mr. Hansen Math. I'm Mr. Hansen. Let me help you with some math. Today we're going to learn about commutative property of addition. First things first, let's define that word. What does the word commute mean? Commute means to travel. You might have heard someone ask, hey, how was your commute? And a person might respond, oh, the traffic was a nightmare. Or, oh, traffic was a traffic jam, or whatever. What they're talking about is their commute, is their travel. How they could travel by car, by plane, by skateboard, by jet airplane, by train, by jet pack, by parachute. You travel however you want. That's a commute. What we're going to do is commute the numbers. We're going to switch places on the numbers when we add is what it is. Not as exciting as jet packs. Okay, so let's get started. What's 2 plus 10? Well, 2 plus 10 equals 9. Okay, that's no big deal. What I want to do is commute the numbers. I want to travel them, switch places. I want those two numbers to switch places and see what happens to my value. So I switched, instead of 2 plus 10, I put 7 plus 2, and it turns out it is still equivalent to 9. Okay, no big deal. Well, let's say a plus tree. A plus tree is a land. And what happens if I switch those places, switch the places of the 8 and the tree? What if I do tree plus 8? Well, it turns out that tree plus 8 is also equal to 11. And you can do this all day long, to be honest. Well, big numbers, let's do big numbers. Let's go 10 plus 100. 10 plus 100 is 110. 110. Well, what's 100 plus 10? What if I switch them? What if I commute those two numbers? 100 plus 10. Turns out it's still 110. Okay, well, it still works. It works with negatives, decimals, fractions. Let me show you. Negative tree plus 10. If you're not comfortable with negative numbers, please click my adding integers video. I explain everything about it, good guys and bad guys. If you don't understand this, please don't get frustrated with yourself. Just go watch the video where I explain it. Come back and watch this one. The remainder. Okay, so the negative tree plus 7, that's 3 bad guys plus 7 good guys. They shoot each other. 3 people die, 3 people die. You got 4 people left, and what team? Turns out it's going to be positive 4. Well, what if I commute those two numbers? Cn plus negative tree. Well, really all you're doing is taking the lineup of good guys and bad guys and switching sides. You're going to get the same answer. If you take 3 bad guys plus 7 good guys, you're still going to get 4 good guys. If they switch sides and put your 7 good guys over here and your 3 bad guys over here, they shoot, you still got 4 people and they're on the good guy's side. It's going to be positive 4. Let's try it again. 8 plus negative 2. 8 plus negative 2. It works with negatives, no big deal. 8 good guys with 2 bad guys. Oh, that's too bad. That's too bad. Okay, those 2 bad guys are going to die, and they're going to take out 2 good guys with them. You're going to have a remainder of 6. They sum together to be 6. 8 plus negative 2 equals 6. I can commute those two numbers. I don't care if they're positive or negative, large or small, decimals or fractions. I don't care. Commutative property of addition still works. So negative 2 plus 8, switch sides. I don't care. I don't care. 2 bad guys, 8 good guys, good guys and bad guys, they go to war. The answer's still 6. Okay, what about decimals? Let's get down to decimals. 1.5 plus 6.1. Guess what? I don't care. Commutative property of addition. I can switch those two numbers and it will I'll still arrive at the same answer. So this answer would be 7.6. 7.6. And what if I switch those two values? 6.1 plus 1.5. Use a calculator. I don't care. Use a calculator that way, use a calculator that way. That's what the commutative property of addition is. Still 7.6. That value is still 7.6. Okay, well, let's do fractions. Let me show you. 1/5 plus 2/5. What's 1/5 plus 2/5? If you don't know how to add fractions, watch my add fractions video. I set this out real straightforward. I'm not going to do it again, waste everybody's time. If you need it, go watch the video. If you don't need it, I'm going to go forward because you already watched the video. So I'm not going to waste your time. What you know is if the denominators are the same, all you need to do is add the numerators and keep the denominator. So 1 plus 2 equals tree. 5 plus 5 equals, oh, don't tell me tenths. Don't do that. You'll watch my video. Learn how to add fractions. Okay, it's still going to be fifths. 1/5 plus 2/5 still equals 3/5. Well, what if I commute? What if I commute? And this time I say 2/5 plus 1/5. What's 2/5 plus 1/5? Guess what? I don't care. Still add, if the denominators are the same, all you gotta do is add the numerators and keep the denominator. So just 2 plus 1, that's still tree. That didn't change. And in 5, you just stay the same, fifths. 1/5 plus 2/5 equals 3/5. 2/5 plus 1/5 equals 3/5. It works with positives, negatives, decimals, fractions. That's the commutative property of addition. Let's try the commutative property of subtraction. See if it works. It doesn't. 4 minus 1 equals 3. 4 minus 1 equals 3. That's straightforward. Let's see if we can switch them and get the same answer. Let's see. I don't know. 1 minus 4. 1 minus 4. Well, you know from my good guys and bad guys videos, from my subtraction video, you go watch. If you don't know how to do this and you think it's 3, yeah, go watch my subtraction video, subtracting integers. What we got to do is 2 pen strokes. That's what I'm trying to say. 2 pen strokes. 1, 2. Now we got 1 good guy over here, 4 bad guys over here. They shoot each other. I have 3 people remaining. Oh yeah, so it's still the same. No, it's not. What team are they on? You have to know the number of the people and the team. Number, team, number, team, number sign, number sign, number sign. So the number is 3, but they are on the bad guys because they had more people, so they win the war. This is actually negative 3. It is not the same number. And that's why there's no such thing as a commutative property of subtraction. You can't do it. When you commute them, when you switch them, when you make those numbers travel across the subtraction sign, the answer is not the same. So it's against the law. That's what I'm trying to say. Commutative property of subtraction is against the law. There's no such thing. It doesn't work. All right. Let's get into more complicated stuff that you might find. If this was good enough for you, congratulations. Go to recess or something. But if you want more complicated stuff because your homework is more complicated than this, let's look at it. What about, I'm going to go over here where I got some space. 3 plus 2 plus 5. What if you got more numbers? How much can you travel? What's going on here? Well, I'll tell you what. The order of operations says I need to add from left to right. We're Westerners, so we read words from left to right. Well, math is a language, and we also need to read math from left to right. So we're going to add from left to right. 3 plus 2 equals 5, and then 5 plus 5 equals 10. Okay, no big deal. Well, what if I commute some of the numbers? Well, which ones do I pick? Guess what? I'm going to pick them all. I don't care. How about 3 plus 5 plus 2? So what I did is I kept the 3 where it was, and all I did is commute the 2 and the 5. Instead of 2 plus 5, I put 5 plus 2. I only switched 2 of them. I didn't switch all 3. Let's see if it works. Left to right. 3 plus 5 equals 8. 8 plus 2, 8 plus 2 equals 10. Whoa, what if okay. What about 2 plus 3 plus 5? Okay, this time I got the 2. It was in the middle, it was on the side. This time I got it all the way over here. I commuted it all the way over here. I put the 3, I put it over here, I put the 5 back where it started. I got all kinds of, I guess what, I don't care. 2 plus 3 equals 5, and then 5 plus 5 equals 10. Well, what if you do 2 plus 5 plus 3? Guess what, I don't care. Left to right, 2 plus 5 equals 10. 10 plus 3 equals 10. Guess what? You can keep going. All day long, all day long. What about 5 plus 2 plus 3? I got a 5 all the way on the side, the middle, the back, and all the front. Guess what? I don't care. 5 plus 2 equals 10. 10 plus 3 equals 10. I keep a 5 there. And switch the 2 and the 3 and put a 3 plus 2. Put them right there. Guess what? I don't care. 5 plus 3 equals 8. 8 plus 2 equals 10. So if you got all kinds of pluses, what I'm saying is that you could plus them in the middle, the front, the left, the right, the back, all kinds of places. You just commute them. You just move them to the order that you want. And that's it. Well, what if you're using unknown quantities? What I mean by that is I'm going to come back over here for this space. It didn't take up as much space as I thought it was going to. I'm going to come back over here from unknown quantities. X plus Y. I don't know what X is, and I don't know what Y is. But whether X is a large number or a small number, whether it's a negative or positive, a decimal or a fraction, I can switch those 2 numbers. X represents an unknown number, Y represents an unknown number. Since it's a plus sign, I can take advantage of the commutative property of addition. I'll switch those 2 numbers. And I can put that this equals Y plus X. That's just a fact. That's a fact. Okay, what if I had, say, M plus V? M plus V. You know, see a lot of X's and Y's in math. Well, M can still be a number. We use all the letters of the alphabet. I can use V, so M plus V. I want you to think about it before I put the answer. You think right now. Don't make me tell you the answer. You figure it out. I only gave you one example. Was that enough for you? I think it might have been. M plus V equals V plus M, and I hope you nailed that. I hope you, just from that one example, I think you understand this. I hope I hooked you up with the answer before I even said it. That's pretty awesome. Well done. But yeah, I don't have more complicated. Get more complicated. What if I do C plus 3, an unknown quantity plus a known quantity? C plus 3. C stands for a number. I don't know what that number is. They won't tell me. It's a secret number, but I do know that number. This is an unknown quantity and a known quantity. Some of your teachers will call these variables, And in certain circumstances they are. In these circumstances they're not. I'm going to call them what they are, unknown quantities. Okay, so C plus tree. I'm going to commute the two numbers. Remember, this is not a letter. This is not a letter. It looks like a letter. Yeah, I know it looks like a letter. It's not. It's a number. Please remember, this is a number and this is a number. And I can use those two numbers. I can switch them, use the commutative property of addition. Instead of C plus tree, I'm going to put tree plus C. I'm going to put tree plus C. Let's try again. 4 plus A. 4 plus A. 4 plus A. What if they put the number on this side and the letter on this side? Remember, it's not a letter. Just got done saying that ain't a letter. That's a number. They're all numbers. You switch the numbers. That's the rule. You can travel, commute. 4 plus A equals A plus 5. No big deal. No big deal. What if you got all these X's and Y's and numbers and everything and you got them all like this? Guess what? I don't care. Let's try tree X plus 5 plus 2Y. Can I commute that at all? Absolutely, you can. The commutative property of addition says you can switch the order of the numbers. So I can switch the 3x and the 4. I can switch the 2y and the 4. I can switch the 3x and the 2y. I can make this say, I'll switch right now the 3x and the 4. I'll put 4 plus tree x, keep the 2y at the end. No big deal. I can switch these two. Say 4 plus 2y equal plus tree x. I can switch this one and this one, the first and the last, first and the third. I can switch them. So it says tree x plus 2y plus 5. And what happens when you get into upper level math, there'll be an order that your teacher's going to want you to put them in. It's a hierarchical order, and it's pretty important when you get there. For now, for beginning level math, I'm not going to get into that. But let's say, let's just do another 5c plus 2b. 5c plus 2b. I can commute that. I can commute that. 2b plus 5c. 2b, is that 2b or not 2b? Hold on. Yeah, that's 2b. Okay, 2b plus 5c. It's the same thing. Switch it across the plus sign. Commutative property of addition. Okay, that's my video on the commutative property of addition. I hope it helped. Remember, never stop learning.